What if everything you thought you knew about the universe was a lie? What if black holes aren't just cosmic voids, but the hidden gateways to time travel, alternate dimensions, and the very fabric of reality itself? Could they be cosmic vaults, storing the deepest secrets of existence? Or are they something far more mysterious beyond anything we can comprehend? From entire galaxies being swallowed whole, to the paradoxes that defy the very laws of physics today, we embark on a journey into the darkest, most mind-bending enigmas of the universe. Are you ready to challenge everything you thought you knew? Let's begin. Timestamps for every paradox are in the description. Dive in whenever you like. The information paradox. Does knowledge disappear forever? Imagine throwing a book filled with centuries of knowledge into a raging fire. The pages turn to ash, but the information isn't truly lost. It transforms. The heat, the smoke, the energy, it all persists in some form. Now, what if I told you that, in the vastness of space, there exists something far more terrifying than fire, something that threatens to erase information completely? Enter the black hole, a cosmic monster so powerful that not even light can escape. Anything that crosses its event horizon is swallowed, lost to the abyss. But here's where things get truly strange. According to quantum mechanics, information, the very fabric of reality, cannot be destroyed. Yet, if a black hole evaporates over time, as Stephen Hawking suggested, where does that information go? Does it simply vanish? If it does, then we're facing one of the greatest paradoxes in physics, the information paradox, a contradiction so profound that it challenges our understanding of reality itself. Because if black holes truly erase information, then the fundamental laws of the universe, laws that govern everything from atoms to entire galaxies, might be incomplete. So, does a black hole permanently delete the past? Or is there a hidden mechanism, something beyond our current understanding, that ensures information survives? Some physicists believe the answer lies in holograms, wormholes, or even the very nature of space-time itself. But the truth? It remains one of the greatest unsolved mysteries in the universe, and if we can solve it, we might just unlock the deepest secrets of reality itself. Are you ready to dive deeper? Hawking radiation paradox. Can a black hole really erase information? A black hole is supposed to be an inescapable prison. Once something falls in, it never comes out. But in 1974, Stephen Hawking made a groundbreaking discovery. Black holes actually evaporate through a strange quantum effect. Hawking radiation is emitted from the event horizon, slowly draining the black hole's mass until it eventually disappears. But if the black hole completely vanishes, what happens to everything it consumed? If information is truly lost, it would violate one of the most fundamental principles of physics, the conservation of information. Some scientists believe Hawking radiation must carry information away in some hidden form, while others suggest information is imprinted on the event horizon like a cosmic hologram. But if neither is true, then we may have to rethink the very structure of the universe itself. Unitarity paradox. Does the universe work in reverse? Rewind time in your mind. A glass shatters, then pieces reassemble into their original form. Smoke drifts backward into a candle. Every process plays in reverse. Sounds impossible, right? But in quantum mechanics, the laws of physics allow time to be reversed. Every process should be able to happen both forward and backward. Yet, black holes seem to break this rule. Once something crosses the event horizon, it's gone. There's no way to retrieve it, no way to reverse time. This is the unitarity paradox, a direct conflict between quantum mechanics and gravity. If the universe follows quantum rules, then nothing should be permanently lost. Every particle should have a way to reconstruct its past. But black holes seem to erase their own history. If we can't resolve this paradox, it might mean our understanding of time itself is incomplete. No-hair theorem paradox. Do black holes erase identity? Imagine two completely different objects, a clock and a planet, falling into a black hole. According to the no-hair theorem, once they cross the event horizon, they become indistinguishable. The only things that matter are the black hole's mass, charge, and spin. But where did the details go? If two completely different objects fall in, but the outside observer sees only a black hole, did all the unique information about those objects just disappear? If black holes truly erase all details except mass, charge, and spin, then we are back to the information paradox. Is the missing data stored somewhere deep inside the singularity? Or does it somehow remain encoded at the event horizon? If the no-hair theorem is correct, then black holes might be nature's ultimate erasers. But that would mean physics, as we understand it, is missing something critical: holographic paradox. Is the universe just a projection? What if everything around you, every star, every galaxy, even you yourself, was nothing more than a hologram? The holographic principle suggests that the entire universe could be a projection of information stored on a lower dimensional surface. And guess what? Black holes may be the key to proving it. When something falls into a black hole, its information isn't necessarily lost. Some theories suggest it gets encoded onto the event horizon, much like a hologram projecting a 3D image from a 2D surface. But if black holes work this way, then maybe the entire universe does too. Does that mean our reality is just a high-resolution projection? Are we living inside a grand cosmic illusion? If the holographic principle is correct, it would completely change our understanding of space, time, and the fabric of reality itself. Quantum cloning paradox. Can information exist twice in a black hole? Quantum mechanics tells us that perfect copies of particles can never be made. This is called the no-cloning theorem. But black holes create a bizarre problem. If information is somehow encoded outside a black hole in Hawking radiation while also remaining inside, doesn't that mean the same information exists in two places at once? That's impossible. Yet, black holes seem to suggest it happens anyway. If information is duplicated, it breaks quantum mechanics. If it's erased, we're back to the information paradox. So which is it? Does information survive? Is it copied? Or do black holes rewrite the very rules of physics? If we crack this mystery, we might finally understand how quantum mechanics and gravity fit together. Firewall paradox. Is there a wall of fire at the edge of a black hole? For decades, scientists believed that if you fell into a black hole, you wouldn't notice anything special when crossing the event horizon, at least until you reach the singularity. But in 2012, a new idea shattered that belief. What if the event horizon wasn't smooth at all, but a raging inferno? This is the firewall paradox. The idea that a black hole's event horizon might be surrounded by an ultra-hot, high-energy wall of radiation. If this is true, anything that tries to cross the horizon would be instantly incinerated. But this creates a massive problem. Einstein's theory of relativity says the event horizon should be a smooth transition. If firewalls exist, then relativity is wrong. But if they don't, then quantum mechanics might be incomplete. So what's the truth? Are black holes smooth gateways, or death traps of pure energy? Virtual particles paradox. How does Hawking radiation carry information? In the quantum world, space isn't really empty. Virtual particles, tiny particle pairs, constantly pop in and out of existence. Near a black hole, one of these particles falls in while the other escapes, becoming Hawking radiation. But here's the mystery. If one particle falls into the black hole while the other escapes, how does any information get out? Shouldn't half of the data be permanently lost? If information is truly preserved, then the escaping particle must somehow encode the details of the one that fell in. But how? Black hole information reconstruction paradox. Can lost data be recovered? Think of a computer that permanently deletes a file. No backup, no recovery, gone forever. That's what black holes seem to do to information. But some physicists believe information isn't actually lost, it's just scrambled beyond recognition. Like an encrypted message, it could still exist in Hawking radiation, but in a form we don't yet understand. If this is true, then nothing in the universe is ever truly lost, even if it falls into a black hole. But if we don't know how to read this hidden data, does it even count as information anymore? If we can unlock the secrets of black hole information reconstruction, we might find that black holes aren't erasers. They're cosmic storage devices. Relativity and quantum conflict. Why do black holes break the rules? Physics is built on two great theories: general relativity, which governs gravity and the large-scale universe, and quantum mechanics, which governs the tiny world of particles. Both of them work perfectly in their own domains, but inside a black hole, they completely contradict each other. Relativity says information must be preserved. Quantum mechanics says it can be lost. Both can't be true at the same time. This is the ultimate battle of physics, two pillars of science, locked in a paradox that defies explanation. If we can solve this mystery, we might not just understand black holes. We might finally unify quantum physics and gravity, solving one of the biggest problems in modern science, Schwarzschild paradox. Why do things never seem to fall into a black hole? Imagine watching an astronaut fall into a black hole. As they approach the event horizon, something strange happens. They slow down. In fact, from an outside observer's point of view, they never actually cross the horizon. Instead, they appear to freeze in time, stuck at the edge forever. But from the astronaut's perspective, they fall in normally. So what's the truth? Do they actually enter the black hole, or do they stay frozen at the horizon? This is the Schwarzschild paradox, and it challenges how we understand time itself. Does the event horizon hold a snapshot of everything that ever fell in? Or is reality different depending on where you observe it from? Many worlds and black holes. Do black holes create new universes? What if black holes don't erase information, but instead create new universes? The many worlds interpretation of quantum mechanics suggests that every possible event spawns a parallel reality. Some scientists believe that when something falls into a black hole, instead of being lost, it branches off into an entirely new universe. If this is true, then black holes aren't destroying matter and information, they're seeding the birth of new realities. Could our own universe have been born from a black hole in another cosmos? If we could prove this, it would mean that every black hole is a portal, and reality itself is constantly branching into infinite possibilities. Entanglement paradox. Can a particle inside a black hole stay connected to one outside? Quantum entanglement is one of the strangest phenomena in physics. Two particles, no matter how far apart, can remain instantaneously connected. But what happens if one of these entangled particles falls into a black hole? According to classical physics, the event horizon is an impenetrable barrier nothing can escape. But quantum entanglement suggests that the two particles should still be linked, sharing information across space instantly. So does the black hole break this connection? Or does entanglement allow information to leak out in a hidden way? If we can understand this paradox, we might find that black holes don't destroy information after all. They just store it in ways we haven't yet realized. Zero information paradox. If black holes erase data, how does the universe preserve it? The universe follows strict laws. One of the most fundamental is that information can never be destroyed. Yet, black holes seem to break this rule. They consume everything and leave behind only mass, charge, and spin. So if black holes truly erase information, does that mean physics is incomplete? Some theories suggest information is stored on the event horizon as a hologram. Others propose that it is somehow released through Hawking radiation, scrambled beyond recognition. But if neither is true, then we have a problem, one that could change our entire understanding of reality. If black holes truly erase data forever, then our universe might be fundamentally flawed. Hawking-Bekenstein paradox. Why is black hole? Makes no sense in standard physics. Why would a black hole's entropy be tied to its surface, rather than what's inside it? Some believe this suggests that black holes store information on their horizon, acting like a cosmic hard drive. Others think it's proof that our entire universe functions holographically, with reality itself being encoded in lower dimensions. If this idea is correct, then everything we experience, even space and time, might be an illusion. Quantum tunneling paradox. Can particles escape a black hole? Imagine standing in front of a locked door. Normally, you'd have to unlock it to get through. But in the bizarre world of quantum mechanics, particles sometimes do something impossible. They teleport through barriers. This is called quantum tunneling. Now, what if particles could tunnel out of a black hole? According to Einstein's relativity, the event horizon is a one-way street, nothing escapes. But quantum mechanics suggests there's always a tiny probability that a particle could tunnel through, bypassing the laws of gravity. If tunneling works inside black holes, then maybe information isn't truly lost, it's just sneaking back into the universe in ways we haven't yet understood. Could this be the hidden key to solving the information paradox? Wormhole information paradox? Do black holes open gateways through space? For centuries, black holes were thought to be dead ends, places where matter and energy are lost forever. But what if they are actually gateways to distant parts of the universe? Some physicists believe black holes might be connected to wormholes, shortcuts in space-time that link one part of the cosmos to another. If true, this could mean information isn't destroyed in a black hole, it's just relocated elsewhere. But there's a problem. Wormholes should collapse instantly unless something, perhaps exotic quantum effects, keeps them open. Could the answer to the information paradox be that black holes don't erase information, but instead Send it through hidden passages in spacetime? Black hole complementarity. Can information exist into places at once? Imagine dropping a book into a black hole. From your perspective, it falls in and disappears. But what if, at the same time, the information in that book remains imprinted on the event horizon as if it never truly fell in? This is the strange idea behind black hole complementarity, which suggests that information is never truly lost, it just exists in two different places at the same time. One version remains outside the black hole, while the other is somehow preserved inside. But if this is true, then black holes don't actually erase data, they just store it in a way that bends the rules of reality. Could this be the secret to how black holes obey both quantum mechanics and relativity? Graviton escape paradox. How does gravity escape a black hole? If light can't escape a black hole, then how does gravity? Gravity is carried by hypothetical particles called gravitons, which should behave just like photons, meaning they shouldn't be able to escape a black hole either. Yet, we still feel the gravitational pull of black holes from far away. This creates a paradox. If nothing can escape a black hole, then how does its gravitational field extend beyond the event horizon? Does gravity work differently inside black holes? Or is there an unknown mechanism that allows it to spread without breaking the rules of physics? If we solve this paradox, we may finally understand the true nature of gravity and whether it's different from every other force in the universe. Observer effect. How does a black hole look to someone falling in? Imagine two people, one falling into a black hole, the other watching from a safe distance. Strangely, both would experience reality differently. To the falling person, they pass through the event horizon as if nothing happened. But to the outside observer, they appear to slow down, never actually crossing the horizon. Instead, they seem to freeze at the edge of the black hole, fading away as light gets stretched and red shifted. So what's the truth? Does the person actually fall in, or do they remain suspended at the horizon forever? The answer depends on where you're observing from, and that makes black holes one of the strangest objects in the universe. Time stops inside a black hole. Does time truly freeze? Time doesn't flow the same everywhere. Near a black hole, gravity is so intense that time slows down dramatically. But what happens inside a black hole? Einstein's equations suggest that for an outside observer, time at the event horizon comes to a stop. This means anything falling in would appear frozen at the edge forever. But from the perspective of the falling object, time continues as usual. So what's the truth? Is time inside a black hole completely frozen? Or does it only appear that way from the outside? If time truly stops at the event horizon, it could mean that everything that has ever fallen into a black hole is still there, just out of reach. Time reversal inside a black hole. Does time flow backward? Time, as we experience it, always moves forward. But black holes bend the very fabric of space-time. Some theories suggest that inside a black hole, time might actually run in reverse. If this is true, it would mean that the laws of physics inside a black hole could be completely different from those outside. Could this explain where the missing information goes? Is the singularity inside a black hole actually the beginning of another universe, one where time moves backward instead of forward? If we ever solve this mystery, we might finally understand what happens on the other side of a black hole. Can we retrieve information from a black hole? For decades, scientists thought that once something fell into a black hole, it was lost forever. But what if there was a way to get it back? Some physicists believe that Hawking radiation might secretly carry information away from a black hole, but it would be scrambled beyond recognition. Others suggest that quantum entanglement might allow us to extract information in a hidden way. But here's the big question. Even if information isn't lost, can we ever reconstruct it? If we could decode the radiation from a black hole, we might not just retrieve lost data, we might unlock secrets about the birth of the universe itself. Does a black hole delete the past? The past is supposed to be set in stone. Once an event has happened, it can't be undone. But black holes challenge this idea. If they erase all the information of what falls in, does that mean they delete the past itself? If black holes truly destroy information, then physics as we know it isn't reversible. That means the past could be permanently lost, violating the fundamental laws of quantum mechanics. But if the past is still stored somewhere, where does it go? Could it be hidden in an alternate dimension? Or is there a way to recover it, perhaps encoded in the very fabric of the universe? If black holes can delete the past, then our entire understanding of reality might be incomplete. Can you see the inside of a black hole from outside? Imagine a spaceship orbiting just outside a black hole. Can the crew inside ever see what's happening past the event horizon? According to physics, nothing inside the event horizon can send signals back out. Light can't escape, which means no information can reach an external observer. But what if quantum mechanics allows for a loophole? Some theories suggest that information might be scrambled and re-emitted in ways we don't yet understand. If this is true, then black holes might not be completely black, they might be cosmic mirrors, reflecting echoes of their past. Could future technology allow us to peer into a black hole's secrets? If so, we might finally unlock the mysteries of what lies beyond the event horizon. Gravitational redshift paradox. Does light ever escape a black hole? Imagine shining a flashlight toward the sky. On Earth, the light moves upward without much trouble, but near a black hole, gravity is so strong that even light struggles to escape. As light climbs away from the black hole, it loses energy, stretching into longer and longer wavelengths. This effect is called gravitational redshift. The closer the light is to the event horizon, the more extreme the shift becomes until, at the very edge, the light is stretched so much that it practically disappears. But does this mean some light almost escapes? Could redshifted photons carry traces of hidden information? If we could decode them, we might glimpse what lies beyond the event horizon. Is the inside of a black hole infinite? We think of black holes as enormous, but their actual singularities where all the mass is concentrated are infinitely small. But does that mean the inside of a black hole is infinite too? Some theories suggest that space-time inside a black hole might be infinitely stretched, meaning that if you fell in, you could travel forever without reaching an end. But other ideas propose that black holes have a finite volume, and the singularity is simply an ultra-dense point rather than an actual infinite structure. If space inside a black hole is infinite, then black holes might not just be objects, they could be entire new universes hidden within our own. Is there a way to survive falling into a black hole? In movies, we often see astronauts getting pulled into black holes and somehow surviving. But could this ever be possible? If you fell into a small black hole, tidal forces would stretch and tear you apart before you even reach the event horizon, a process called spaghettification. But in a supermassive black hole, the gravitational gradient is much weaker, meaning you could actually cross the event horizon without immediately dying. But what happens after that? Some theories suggest you'd be crushed at the singularity. Others speculate that you might fall into another part of the universe, or even a different reality altogether. Could black holes be the gateways to something beyond our understanding? Could we use black holes for energy? Black holes consume everything in their path, but what if we could harness that power instead? Theoretically, a rotating black hole could be used as an energy source by extracting energy from its spinning motion. This is called the Penrose process, and it suggests that by carefully dropping matter near the event horizon, we could gain enormous amounts of energy in return. Some scientists even believe that advanced civilizations could use black holes as giant cosmic batteries. If we could master this technique, we might unlock a nearly infinite energy supply, allowing us to power interstellar travel and even manipulate gravity itself. Could black holes be the ultimate power source of the future? Are black holes older than the universe? The universe is estimated to be about 13.8 billion years old. But what if black holes existed before the Big Bang? Some physicists propose that primordial black holes, tiny black holes formed in the first moments of the universe, might have been around before time itself began. If this is true, then black holes aren't just a product of the universe. They may have helped create it. Could black holes be remnants of a previous cosmos? If so, they might hold secrets about what came before our universe, and perhaps even what will happen after it ends. Could a black hole swallow the universe? Black holes consume everything in their path, but could they ever grow so large that they devour the entire universe? Theoretically, no. While black holes can merge and expand, their gravitational pull weakens as you move farther away. The expansion of the universe also works against them, pushing galaxies apart faster than a black hole could possibly pull them in. However, there is a terrifying possibility. If a supermassive black hole grew large enough and somehow triggered a chain reaction, it could create a self-sustaining collapse. Could this mean that, billions of years from now, the universe might end in a black hole apocalypse? If that happens, would everything be lost? Or could a new universe be born from the ashes? Could black holes be conscious? What if black holes weren't just objects, but something more aware? Some scientists propose that black holes may function like neural networks, storing and processing vast amounts of information. If information isn't lost but encoded on the event horizon, does that mean black holes could be thinking in ways we don't understand? This idea sounds like science fiction. But if black holes are cosmic computers, could they store memories of past civilizations? Could they even be a form of intelligence beyond our comprehension? What if the answers to our biggest questions aren't in space but inside the black holes themselves? What happens if two black holes merge? When two black holes collide, something extraordinary happens. They spiral around each other, moving faster and faster, until they slam together with mind-bending force. The result? A massive explosion of gravitational waves, rippling through space-time at the speed of light. This is one of the most violent events in the universe, warping reality itself. But what happens to the information stored in both black holes? Does it combine into a single, larger entity? Or is something lost in the process? If we could decode these collisions, we might learn the hidden structure of black holes and maybe even prove whether information truly survives. Could black holes turn into white holes? A black hole pulls everything in, allowing nothing to escape. But what if there was an opposite, a white hole that expels everything and never lets anything enter? Some theories suggest that black holes might eventually transform into white holes, ejecting all the matter and energy they once consumed. This could mean that information isn't lost, it's just stored and released in an entirely different way. If black holes become white holes, where do they send the information? Could it be transmitted to another universe? And if so, could that explain the mystery of the Big Bang itself? Do black holes have a temperature? At first glance, black holes should be completely cold, nothing can escape them, so how could they radiate heat? But Stephen Hawking's research showed that black holes do have a temperature, and they slowly. Tiny black holes could be hotter than the sun, while giant supermassive black holes are incredibly cold. But here's the paradox: if black holes radiate energy, that means they must be losing mass. If left alone long enough, could a black hole completely evaporate, leaving nothing behind? If so, what happens to all the information it swallowed? Does it return to the universe or is it lost forever? Could a black hole explode? Black holes are known for consuming everything in their path, but could they ever explode instead? Under normal circumstances, black holes don't detonate like stars. However, as they emit Hawking radiation, they slowly lose mass. If a black hole gets small enough, it could reach a critical point where it suddenly evaporates in a burst of energy, a quantum explosion unlike anything we. Some theories suggest that tiny primordial black holes, formed after the Big Bang, might have already exploded, releasing huge amounts of radiation. But what if larger black holes could also explode? Would they unleash a final burst of information back into the universe? If black holes can explode, it could mean they aren't just cosmic traps, but ticking time bombs. Could you orbit inside a black hole? When we think of a black hole, we imagine an object falling straight into the singularity. But what if, instead of falling, you could orbit inside it? In some theories, inside the event horizon of a rotating black hole, there may be a special region where space-time is so warped that stable orbits are possible. Instead of being crushed instantly, matter and even light might spiral around in endless loops, never reaching the center. Could this mean there are hidden structures inside black holes, places where matter exists in a strange, suspended state? If so, could something survive inside a black hole longer than we ever imagined? Could a black hole be spinning near the speed of light? Black holes don't just sit still, they spin, and some of them may be rotating at nearly the speed of light. When a massive star collapses, its rotation increases dramatically, just like an ice skater pulling in their arms. The result? A curved black hole, an object spinning so fast that it drags space-time along with it. If a black hole spins fast enough, strange things start happening. It might create a ring-shaped singularity, or even allow matter to escape through a hidden passage. Could this mean that some black holes act as natural wormholes, linking different points in space? And if a black hole spins too fast, could it tear itself apart? Could we artificially create a black hole? Black holes are formed by collapsing stars, but could humans one day create one? Theoretically, if we compressed enough mass into an extremely small space, we could generate a tiny black hole. Some theories even suggest that high-energy particle collisions like those in the Large Hadron Collider could briefly create microscopic black holes. If we could control these tiny black holes, they could revolutionize energy production, gravity research, and even space travel. But there's a risk. What if an artificial black hole grew uncontrollably? Could our attempts to harness black hole technology end up swallowing the Earth? Do black holes have magnetic fields? Black holes are known for their intense gravity, but they also create some of the strongest magnetic fields in the universe. As matter falls toward a black hole, it forms an accretion disk, a swirling ring of superheated plasma. This motion generates enormous magnetic fields, powerful enough to launch jets of energy that extend thousands of light years into space. But where does this energy come from? If nothing escapes a black hole, then how do these massive jets manage to shoot outward at near light speeds? Could they be carrying hidden information that black holes are secretly releasing? If we understand how black holes generate these magnetic fields, we might uncover new ways to manipulate energy on a cosmic scale. Could a black hole turn into a star again? Black holes are the end stage of a star's life, but could they ever return to their former state? Some theories suggest that if a black hole gains enough energy or undergoes a radical transformation, it could reignite, forming a new kind of object. Perhaps the information and matter trapped inside could be released, creating a reborn star unlike any we've ever seen. If this is possible, could it mean that black holes aren't the final stage of a star's life, but rather a transition into something else? What happens if a black hole enters a galaxy's core? Most galaxies, including our Milky Way, have a supermassive black hole at their center. But what if an extra black hole drifted in and merged with it? If a rogue black hole entered the galactic core, it could trigger a massive gravitational event, disrupting stars and possibly causing some to be flung into intergalactic space. Could such an event reshape an entire galaxy? And if the black hole is powerful enough, could it swallow the entire core, changing the structure of the galaxy forever? Are black holes the seeds of new galaxies? We often think of black holes as destroyers, but could they actually be creators? Some scientists believe that black holes might be responsible for shaping and structuring galaxies. As they consume matter, they also release enormous amounts of energy, which could trigger the formation of new stars and planetary systems. If black holes are the seeds of galaxies, does that mean every galaxy in the universe owes its existence to one? And if so, what does that mean about the fate of our own galaxy? Could a black hole warp time to the point of breaking? Black holes already slow down time due to their immense gravity, but could a black hole bend time so much that it completely breaks down? Some theories suggest that at a black hole's singularity, time ceases to function altogether. If true, this would mean that inside a black hole, there is no past, present, or future, just an incomprehensible state where time is meaningless. Could this mean that black holes contain regions of timeless space, where physics as we know it simply stops working? And if time inside a black hole is truly broken, is there any way to restart it? Could black holes create new dimensions? We live in a three-dimensional world, but what if black holes are connected to higher dimensions? Some physicists propose that when matter is pulled into a black hole, it might be transported into extra dimensions beyond our current understanding of space and time. If this is true, then black holes aren't just pulling matter inward, they could be redirecting it somewhere entirely new. Could black holes be the gateways to other dimensions? And if so, is it possible to find a way through them? Could a black hole reverse entropy? Entropy is the measure of disorder in the universe. It always increases over time. But black holes don't follow normal rules. When they consume matter, all the complexity of that matter is seemingly erased, leaving behind only mass, charge, and spin. Does this mean that black holes are somehow reversing entropy, undoing the natural tendency of the universe? If so, black holes might hold the key to understanding the deep connection between gravity, thermodynamics, and quantum mechanics. Could they be nature's way of resetting information? And if entropy can be reversed inside a black hole, could it happen elsewhere in the universe? Can a black hole become so large that it collapses on itself? We know black holes can merge and grow larger, but is there a limit to how big they can get? Some supermassive black holes are billions of times the mass of the sun, consuming enormous amounts of matter. But if a black hole grows too large, could its own mass cause it to collapse into something even stranger, perhaps a new state of matter or even a universe of its own? If there's a size limit to black holes, we don't yet know what it is. Could the biggest black holes be approaching a point where they transform into something we can't yet imagine? Could there be planets orbiting inside a black hole? We typically think of black holes as places of destruction, but some physicists speculate that inside certain types of black holes, stable orbits might be possible. If true, it could mean that Entire planets or even civilizations could exist within a black hole, completely isolated from the rest of the universe. But there's a problem. How would light and energy work in such an environment? Would time move faster or slower than in our universe? If planets can exist inside black holes, then we have to ask, could someone be living there right now? Could a black hole swallow a wormhole? Wormholes are theorized to be tunnels through space-time, connecting distant points in the universe. But what if a black hole engulfed one? Would the wormhole collapse under the black hole's extreme gravity, or could it actually survive, creating an even stranger object, a black hole wormhole hybrid? If wormholes can exist inside black holes, it could mean that black holes don't just trap matter. They might be rearranging space-time itself in ways we can't yet understand. Could this be a key to faster than light travel? Could black holes form inside other black holes? If a smaller black hole falls into a larger one, does it simply merge? Or could it create a nested structure, where black holes exist inside other black holes? If this is possible, it means the inside of a black hole might not be empty. It could contain an entire hierarchy of black holes, stacked within each other like a cosmic Russian doll. If black holes can form within black holes, does this mean space itself is layered? Could our own universe be inside a black hole right now? Could black holes be the building blocks of a new universe? When a massive star collapses, it creates a black hole, a place where gravity is so strong that nothing can escape. But what if black holes don't just destroy matter and information? What if they actually seed the formation of new universes? Some theories suggest that when a black hole forms, its singularity doesn't just collapse into an infinite point, it might bounce into a new reality, where the laws of physics evolve differently. This idea is known as the black hole cosmology hypothesis, where every black hole could give birth to a separate universe. If this is true, then our own universe could have been born from a black hole in a parent cosmos. That would mean black holes aren't just objects in space, they might be the key to an infinite chain of universes, each created inside the singularities of black holes. If we could prove this, it would mean that every time a black hole forms, it's not an end, it's a new beginning. But if that's true, then what happens if we enter one? Could black holes leak into other universes? For decades, we've believed that anything falling into a black hole is lost forever, trapped beyond the event horizon. But what if black holes aren't actually dead ends? What if they are bridges to other universes? Some physicists propose that black holes don't just swallow matter, they might actually transport it elsewhere. This idea comes from wormhole physics, which suggests that black holes and wormholes might be connected, forming shortcuts through space-time. If this is true, then the singularity inside a black hole could be a doorway to another universe with different physical laws. Could this explain where the missing information goes? If matter and energy aren't destroyed, but instead leak into another reality, then black holes might be functioning as cosmic gateways. And if black holes lead to other universes, is it possible that something could come back through them? Could we one day travel through a black hole? Science fiction often portrays black holes as portals for space travel, but could this actually be possible? Theoretically, a rotating black hole called a Kerr black hole might not have a single crushing singularity. Instead, it could have a ring singularity, which might allow passage through without being destroyed. Some physicists believe that if you entered a Kerr black hole at the right angle, you might be able to emerge somewhere else in the universe or even in another reality. But the problem is stability. Any small disturbance could collapse the passage, trapping anything inside forever. If we ever develop the technology to control gravity, could we stabilize these wormhole-like structures inside black holes? If so, then black holes wouldn't just be cosmic mysteries, they'd be intergalactic highways. Could the key to faster than light travel be hidden inside black holes? And if so, has another civilization already figured this out? Could a black hole become a white hole? A black hole pulls everything in. A white hole does the opposite, it pushes everything out and never lets anything enter. But could a black hole eventually transform into a white hole? Some theories suggest that black holes aren't actually permanent, as they evaporate due to Hawking radiation. They could reach a critical point where they flip into white holes, releasing all the trapped information back into the universe. This could explain a major mystery. If information isn't truly lost, where does it go? If black holes eventually turn into white holes, it means that every black hole is like a cosmic storage device, waiting for the right moment to unleash everything it has absorbed. Could this process explain the Big Bang? Was our universe born from a white hole explosion that was once a black hole in another reality? Could black holes be quantum computers? What if black holes aren't just cosmic voids, but the most powerful quantum computers in the universe? Physicists have discovered that black holes store information in a way that's eerily similar to how quantum computers encode data. The holographic principle suggests that all the information inside a black hole is imprinted on its event horizon, just like bits of data in a quantum processor. If black holes function like quantum computers, could they be performing calculations at a cosmic scale? Could they be simulating realities, processing vast amounts of data, or even storing the information of entire civilizations? And if that's true, could someone or something be using black holes for a purpose beyond our understanding? Could black holes contain the blueprint of the universe? Imagine if the entire universe, every planet, every star, and every moment of history was encoded inside a black hole, like a cosmic hard drive. Some physicists believe that black holes aren't just swallowing information. They might actually be storing it in ways we can't yet comprehend. According to the holographic principle, all the information about everything that has ever fallen into a black hole might be preserved on its event horizon, a two-dimensional surface encoding a three-dimensional reality, much like a hologram. If this is true, then black holes might contain a perfect record of the past, including galaxies that no longer exist. But here's where things get really strange. If every black hole is storing vast amounts of cosmic data, does that mean we could one day decode it? Could we extract the history of the universe from a black hole's surface? And if black holes store information instead of erasing it, does that mean the universe itself could be a simulation, running on the most advanced quantum system in existence? What would happen if you fell into the largest black hole in the universe? Falling into a black hole is usually a death sentence. But what if you fell into the largest black hole in existence, 1 billions of times the mass of our sun? In a small black hole, you'd be stretched and torn apart by extreme tidal forces in a process called spaghettification long before you reach the event horizon. But in a supermassive black hole, the gravitational pull is so evenly spread that you could cross the event horizon without even noticing. So what happens next? Some theories suggest that you'd be pulled toward the singularity and crushed by infinite gravity. But others propose something even stranger. Inside a massive black hole, space-time itself might be stretched in such a way that you could survive for a long period, possibly forever, without ever reaching the center. Could this mean that inside supermassive black holes, there could be entire hidden realms, where time moves differently and physics operates in ways we don't yet understand? If so, could something already be living in there? Could black holes rewrite the laws of physics? We assume the laws of physics are universal, applying everywhere in the cosmos. But what if black holes are exceptions to the rule? Inside a black hole, everything we know about space, time, and even causality breaks down. The equations of general relativity predict an infinite density at the singularity, something that shouldn't be possible. And quantum mechanics, which governs the smallest particles in the universe, doesn't seem to work inside black holes either. This means black holes aren't just strange objects. They could be places where the laws of reality fundamentally change. If we could understand what happens inside a black hole, we might discover entirely new physics, perhaps even new forces or dimensions. Could black holes be portals to new physical laws, where different rules govern the way the universe operates? And if so, could this explain why the universe itself seems fine-tuned for life? Could black holes merge to form a bigger universe? When two black holes collide, they merge into a single, larger black hole, releasing massive gravitational waves in the process. But what if, instead of just forming a bigger black hole, the merging process could create something much larger, a new universe? Some theories suggest that extreme conditions inside merging black holes might trigger a process similar to the Big Bang, where a new self-contained space-time bubble emerges. If this is true, it could mean that black holes don't just consume matter, they might be the building blocks of entire new realities. This raises a fascinating possibility. Could our own universe have been created by the merger of two black holes in a previous cosmos? If so, then black holes aren't just remnants of dead stars, they could be the seeds of existence itself. And if we could one day control black hole collisions, could we create an entirely new universe? Could black holes lead to the end of the universe? We know that black holes can swallow stars, planets, and even entire galaxies, but could they eventually consume everything? Some theories suggest that as black holes continue to merge and grow, they could become so massive that they dominate the universe's structure. If all matter eventually falls into black holes, the cosmos might reach a state where nothing remains except a vast, empty void filled with evaporating black holes, a fate known as the black hole era. Even worse, some theories propose that the expansion of the universe might slow down or reverse, causing black holes to merge into one final, ultimate singularity, essentially a big crunch, where everything collapses into one final, inescapable point. If black holes are the engines of destruction, then what comes after them? Do they simply fade away, leaving an empty universe behind? Or could their remains spark the birth of something new? Could the universe itself be trapped in an endless cycle of creation and destruction, all driven by black holes? Could black holes be the key to understanding dark matter? Dark matter is one of the biggest mysteries in physics. We can't see it, we can't touch it, but we know it's there, shaping galaxies and bending space-time. But what if black holes are the missing link? Some theories suggest that dark matter could be made up of primordial black holes, tiny black holes that formed in the early universe. These objects would be invisible, just like dark matter, yet their gravity could explain why galaxies behave the way they do. But there's another possibility. Black holes might not be made of dark matter, but instead, they could be interacting with it in ways we don't yet understand. Could black holes act as cosmic detectors for dark matter, revealing its hidden nature? If we solve this mystery, we might finally unlock one of the greatest secrets of the universe. Could black holes warp reality itself? We know black holes warp space and time, but could they bend reality itself? Near a black hole, space-time is stretched to the extreme, creating conditions where physics starts to break down. Some theories suggest that black holes could even affect causality, meaning that what happens inside could influence the past, present, and future in ways that seem impossible. Even more bizarre, some physicists propose that black holes could create closed time loops, where an event can cause itself to happen. If this is true, could black holes hold the key to understanding time travel? Could they be natural machines that allow us to step outside the flow of time itself? Could black holes be tunnels to parallel universes? Some physicists believe black holes might be more than just gravitational traps. They could be gateways to parallel universes. According to certain interpretations of quantum mechanics and relativity, a black hole's singularity might not just be an endpoint. Instead, it could be a passage to another dimension, where the laws of physics operate differently. If this is true, then anything falling into a black hole wouldn't be destroyed, it would be transported elsewhere. Could this mean black holes aren't really consuming matter, but rather relocating it to another reality? And if black holes connect to parallel universes, could something already be coming through from the other side? What if a black hole passed through the solar system? Black holes are terrifying enough from a distance, but what if one drifted into our solar system? Even a tiny black hole, with the mass of an asteroid, could wreak havoc, disturbing planetary orbits and possibly swallowing anything in its path. A larger black hole could completely disrupt the sun's gravitational hold, throwing planets into deep space or pulling them directly into the black hole itself. Scientists believe rogue black holes may be wandering the universe, unseen until they pass too close. Could one already be approaching us? And if so, would we even see it coming before it's too late? Could we use black holes for time travel? Time slows down near a black hole, but could we use this effect to travel into the future? According to Einstein's theory of relativity, time moves slower in stronger gravitational fields. This means that if you orbited a black hole for a few years and then returned to Earth, you might find that centuries had passed for everyone else. But what about traveling into the past? Some theories suggest that black holes, especially rotating ones, could form loops in space-time, potentially allowing for backward time travel. If black holes hold the secret to time travel, could they be the key to escaping our own timeline? Or is the idea of using black holes as time machines just science fiction? Could a black hole destroy space-time? We think of space-time as unbreakable. But what if black holes could tear it apart? Inside a black hole, space-time becomes infinitely warped. Some physicists believe that if a black hole becomes too massive, its gravitational pull could stretch the fabric of reality so much that it shatters, creating a rupture in the universe itself. Could this mean that some black holes aren't just consuming matter, but actively eroding spacetime? And if that's the case, could there come a point when the universe itself collapses under its own weight? Could black holes spit matter back out? Black holes consume everything, but could they also spit things back out? Some theories suggest that instead of crushing everything into a singularity, black holes could eventually release the matter they've swallowed. This could happen through jets of energy, white hole counterparts, or even quantum processes we don't yet understand. If this is true, then black holes aren't just one-way cosmic vacuums, they could be part of a much larger process of destruction and rebirth. Could they be responsible for seeding the universe with new matter after holding onto it for billions of years? Could we survive the end of the universe using black holes? If the universe is destined to end, could black holes be our lifeboats? Some theories suggest that in a far future where stars burn out and galaxies fade away, black holes might be the last remaining sources of heat and energy. Advanced civilizations could live around black holes, extracting energy from them to survive. But what happens after that? If the last black holes eventually evaporate, is there any way to escape the end of everything? Could black holes somehow provide a way to travel to a new universe where life can begin again? Could a civilization harness the power of a black hole? A Type 3 civilization on the Kardashev scale would have the ability to control energy on a galactic scale. But what if a civilization went even further, harnessing the power of a black hole itself? By using a supermassive black hole's rotation, they could generate near-limitless energy. They might even manipulate gravity to create artificial wormholes, or extend the lifetime of their own civilization. If an ancient alien race had already mastered black hole technology, could they be using them for intergalactic travel? And if so, could the mysterious structures we see in space be the remnants of their work? Could black holes be life forms? It sounds absurd, but could black holes be alive in some way? Some physicists speculate that highly advanced forms of intelligence wouldn't need biological bodies. Instead, they could exist as pure energy, encoded in the gravitational waves of black holes. If black holes can store and process information like quantum computers, could they have some form of awareness? Could they even be communicating through the gravitational waves they emit? And if black holes are alive, what would they think of us? Could black holes be the key to immortality? Humans have always searched for ways to extend life. But what if the answer isn't found in medicine or technology? What if it's hidden inside black holes? Near a black hole, time slows down drastically due to extreme gravitational forces. If you could orbit a black hole safely, you could experience a few days while centuries pass in the outside universe. This means black holes could be used as time shelters, allowing someone to experience extended life relative to the rest of the cosmos. But what about actual immortality? Some theories suggest that if black holes preserve information, they could also preserve the data that makes up a human mind. If consciousness could be digitized and encoded on a black hole's event horizon, would that mean a person's identity could live forever? If black holes store everything they consume, could they be the ultimate vaults of existence, keeping a record of everything that has ever fallen into them? Could this mean that, in some form, nothing is ever truly lost, not even us? Could a black hole collapse into something even stranger? We think of black holes as the end stage of a star's life, but what if they aren't the final destination? Could a black hole collapse further, transforming into something even more extreme? Some theories suggest that once a black hole grows massive enough, quantum mechanics might kick in, preventing it from collapsing into a singularity. Instead, it could become a gravistar, a bizarre object where gravity is perfectly balanced by exotic quantum forces, creating a hollow space inside. Another possibility? Planck stars, a theoretical concept where, instead of collapsing infinitely, the black hole undergoes a quantum rebound, effectively bouncing back and releasing all of its stored energy in a massive explosion. If either of these ideas is true, it means black holes aren't permanent, they're evolving. Could this mean that, one day, every black hole will transform into something we haven't yet imagined? Could a black hole become sentient? What does it mean to be alive? Does it require cells and DNA, or can intelligence exist in a completely different form? Some physicists have speculated that black holes could act like natural quantum computers, storing and processing information on their event horizons. If black holes can store vast amounts of data, could they eventually become aware of their own existence? Imagine an entity that doesn't think in words, but in gravitational waves, a consciousness spread across the surface of an event horizon, experiencing time in ways we can't comprehend. If intelligence can exist in non-biological forms, then could black holes be cosmic minds, thinking on scales far beyond our own? And if so, could we ever learn to communicate with them? Could a black hole split in two? We know black holes merge when they collide, but could the opposite happen? Could a black hole split apart, forming two smaller black holes? In classical physics, this shouldn't be possible once a singularity forms, it should remain intact. However, some quantum gravity theories suggest that black holes might undergo fission-like processes, where extreme energy fluctuations could cause them to divide. If this is true, then black holes aren't static objects, they might be dynamic, ever-changing entities that can reshape themselves under the right conditions. Could this explain some of the mysterious cosmic bursts of energy we observe in deep space? And if black holes can split, does that mean they could also multiply, seeding new singularities across the universe? Could black holes be used to create artificial gravity? Gravity is one of the biggest challenges in space travel. Without it, astronauts experience severe health issues, and long-term missions become nearly impossible. But what if black holes could provide a solution? If we could control tiny, artificially created black holes, they could act as stable gravity generators, providing weight in space stations or even artificial planets. A small enough black hole, carefully balanced, could pull objects toward it just enough to simulate Earth's gravity without swallowing everything. The biggest challenge? Stability. An artificial black hole would need constant management to prevent it from collapsing or growing too large. But if we ever master this technology, we might be able to terraform planets, build artificial worlds, or even create floating cities in space powered by black hole gravity. Could black holes be the key to making interstellar life possible? Could a black hole be turned into a weapon? Black holes are among the most powerful forces in the universe, so could they be used as weapons? A small artificial black hole could be launched at a planet, consuming everything in its path and leaving behind nothing but a dense singularity. But even without direct impact, black holes could be used as gravitational disruptors, flinging objects at near light speeds toward targets. Even worse, if an advanced civilization could control a supermassive black hole, they could potentially manipulate time, creating time distortions or even erasing history itself. The ultimate question is, if intelligent life elsewhere in the universe has already mastered black hole technology, would we even stand a chance against them? Could a civilization survive inside a black hole? We assume that falling into a black hole means instant destruction. But what if that's not true? Could an advanced civilization actually survive inside? 1. Certain models suggest that the interior of some rotating black holes might contain stable regions where gravity and time behave differently. If an advanced species discovered a way to manipulate quantum physics, they might be able to exist inside the event horizon, shielded from the outside universe. If this is possible, could black holes actually be hiding entire civilizations, completely undetectable to us? And if so, could one day we figure out how to join them? Could a black hole ever be fully controlled? Right now, black holes are untouchable cosmic phenomena, beyond human reach. But could there come a time when we learn to control them? If we could manipulate space-time on a quantum level, we might be able to stabilize black holes, preventing them from growing uncontrollably. We might even be able to harness their power, extracting Hawking radiation as an endless energy source. But what would that mean for the future of space travel? Could we use black holes to create faster-than-light engines, bending gravity to move through space at impossible speeds? If black holes could be controlled, it would mean the end of cosmic limitations and the birth of an entirely new era of exploration. Could a black hole swallow an entire galaxy? We know black holes can consume stars, planets, and even light itself. But could one grow large enough to devour an entire galaxy? At the heart of most galaxies lies a supermassive black hole, millions or even billions of times the mass of our sun. These cosmic giants act like anchors, keeping their galaxies together. But what if, instead of stabilizing a galaxy, a black hole started pulling everything inward? In theory, if a black hole gained enough mass, perhaps through repeated mergers, it could become powerful enough to overcome the gravitational balance holding a galaxy together. Stars and planets would be dragged inward, spiraling toward oblivion in a slow but inevitable collapse. But here's where things get even stranger. If a black hole swallowed an entire galaxy, what would it become? Could it trigger the birth of a new universe inside itself? And if galaxies are slowly being consumed by their central black holes, does this mean the entire cosmos is shrinking one galaxy at a time? Could we create a black hole on Earth? The idea of creating a black hole on Earth sounds like a doomsday scenario, but is it even possible? Particle accelerators like the Large Hadron Collider (LHC) smash protons together at near light speeds, recreating conditions similar to those in the early universe. Some scientists speculate that these high-energy collisions could, in theory, produce tiny, microscopic black holes. But should we be worried? Fortunately, quantum physics suggests that even if microscopic black holes form, they would evaporate almost instantly due to Hawking radiation vanishing before they could do any damage. However, what if we could control the process? Could we generate artificial black holes as power sources, creating unlimited energy? Or if something went wrong, could we accidentally create a black hole that doesn't disappear, one that starts consuming the Earth from the inside out? Could a black hole ever reverse its gravity? We think of black holes as objects with inescapable gravity, pulling everything inward. But what if that force could be reversed? Some exotic theories suggest that if certain quantum effects exist, black holes could actually repel matter instead of attracting it. This could mean that instead of consuming everything, a black hole could suddenly start expelling energy and mass in a violent eruption, possibly transforming into a white hole. If this is possible, it could mean that black holes aren't eternal. Instead, they might have life cycles, transitioning between phases of consumption and explosion. Could this explain some of the mysterious high-energy cosmic bursts we detect in deep space? And if black holes can reverse their gravity, could they, one day, push matter outward with enough force to reshape the universe? Could a black hole pull an entire star apart without swallowing it? Most people assume that if a star gets too close to a black hole, it's simply swallowed whole. But sometimes something even more dramatic happens, a tidal disruption event. Instead of consuming the star immediately, a black hole's gravity can tear it apart, stretching it into a thin stream of gas while some of the material escapes back into space. This process releases an enormous amount of energy, sometimes shining brighter than an entire galaxy for months or even years. But here's the mystery: if a black hole can rip a star apart without swallowing all of it, does this mean that some stars survive close encounters with black holes? Could stars that pass near black holes be reshaped into something new, denser, hotter, or even rejuvenated? And if black holes can transform stars instead of just destroying them, could the same thing ever happen to a planet, or even an entire solar system? Could two black holes orbit each other forever? When two black holes meet, they usually spiral toward each other and eventually merge, creating massive gravitational waves. But what if two black holes were caught in a perfect gravitational balance, orbiting one another forever without colliding? Theoretically, this could happen if both black holes were evenly matched in mass and speed, maintaining a stable binary orbit. If this were the case, these twin black holes could dance around each other for billions of years, emitting only faint gravitational waves. But would this delicate balance last forever? Over time, tiny fluctuations might destabilize the system, forcing the black holes to either collide or drift apart. If two black holes can orbit indefinitely, could they be used as cosmic beacons, emitting predictable gravitational signals that could be detected across the universe? Could an advanced civilization use them as natural timekeepers, marking the passage of cosmic history? Could a black hole capture a rogue planet? The universe is full of rogue planets, worlds that drift through space, unbound to any star. But what would happen if one of these planets strayed too close to a black hole? If a rogue planet approached at the right angle and speed, it wouldn't necessarily fall straight in. Instead, it could be caught in a stable orbit, circling the black hole like a moon around a planet. If this happened, the planet might experience extreme tidal forces, heating up its core and possibly even creating liquid oceans and an atmosphere, making it a strange, habitable world orbiting the ultimate cosmic abyss. Could black holes have hidden planetary systems, with rogue worlds warmed by radiation instead of sunlight? And if so, could there be life on a planet orbiting a black hole? Could black holes be the ultimate cosmic storage devices? What if black holes weren't just engines of destruction, but actually the safest places to store information? According to the holographic principle, everything that falls into a black hole isn't lost, it gets encoded on the event horizon. If this is true, black holes might be the most secure places in the universe, locking away data where no one could retrieve it, except someone who understands the secrets of black hole physics. If an advanced civilization wanted to store its knowledge for billions of years, could it do so inside a black hole, knowing that it would remain untouched by the universe's natural destruction? Could black holes be the ultimate cosmic vaults, containing the history of long-lost civilizations, waiting for someone to unlock them? And if we learn to read black holes like data drives, could we recover the secrets of the universe itself? Could black holes be the seeds of a future universe, We often think of black holes as the endpoints of matter, consuming everything that crosses their event horizon. But what if they are actually the beginning of something new? Some theories suggest that the singularity inside a black hole might not just be a crushed point of infinite density, it could be the starting point of a new universe. Instead of everything collapsing forever, the intense gravitational compression might trigger another Big Bang inside, creating a separate bubble of space-time that expands just like our own cosmos. If this is true, then every black hole in our universe could be a portal to a new reality. And if our own universe was born from a black hole in a previous cosmos, does that mean black holes are part of an endless cycle of creation and destruction, spawning universe after universe? If we could enter a black hole safely, would we find ourselves in another world, one where the laws of physics are completely different? Could a black hole erase the concept of time? Time is something we experience every day, moving forward second by second. But near a black hole, time doesn't behave normally. Due to extreme gravity, time slows down dramatically as you approach the event horizon. But what happens inside a black hole? Some physicists believe that time as we understand it might completely break down inside the singularity, meaning that past, present, and future might cease to exist in a way we can comprehend. If time inside a black hole is meaningless, then what happens to anything that falls in? Does it become frozen in an eternal state, never truly reaching the singularity? Or does it enter a new form of reality, one where time works in ways beyond human understanding? Could black holes be the key to solving the deepest mystery in physics? What is time, really? Could a black hole swallow a neutron star without destroying it? Neutron stars are some of the most extreme objects in the universe, small, dense, and packed with unimaginable pressure. But what happens when a neutron star falls into a black hole? Normally, you'd expect the black hole to simply devour the neutron star. But some scientists believe that if conditions are just right, the neutron star might survive for a short period, orbiting inside the black hole before eventually collapsing. Even stranger, some models predict that neutron stars could merge with the singularity itself, adding their unique properties to the black hole in a way we don't yet understand. Could this process create a new kind of exotic matter, something beyond what we've ever seen? If we could study neutron stars being consumed by black holes, we might learn more about the true nature of matter under extreme conditions. Could we use a black hole to travel faster than light? Interstellar travel is one of humanity's biggest challenges. But what if black holes could provide the answer? Some scientists suggest that the intense warping of space-time around a black hole could, in theory, allow for faster-than-light travel. Instead of moving through normal space, a spacecraft could ride the gravitational currents around a black hole, effectively bending space and shortening the distance between the points. This concept is similar to a warp drive, where space itself is manipulated to allow faster-than-light movement without violating relativity. But the challenge is control. How do you navigate safely around an object that could crush you instantly? If we ever master black hole physics, could we use them as cosmic highways, traveling across the universe in ways we never imagined? Could black holes be nature's hidden shortcuts across the stars? Could a black hole contain an entire universe inside it? What if everything we see, the galaxies, stars, and planets, was actually inside a black hole right now? Some physicists propose that what we call our observable universe could actually be the interior of a black hole formed in a larger parent cosmos. If this is true, then the Big Bang wasn't the beginning of everything, it was simply the moment when a new black hole formed in another reality. This idea would explain some strange aspects of physics, such as why the universe has a finite but expanding size, and why the laws of physics seem fine-tuned for life. Could it be because our universe is part of a much larger system, existing within another black hole? And if that's true, then what happens when our universe's black hole eventually evaporates? Does it mean the end of everything, or could it simply give birth to yet another universe? Could we ever extract energy from a black hole? Black holes trap everything. But what if we could harness their power instead? One possible method is the Penrose process, where objects are thrown into a rotating black hole at just the right angle, allowing energy to be extracted from its spin. This could, in theory, produce enormous amounts of energy, far beyond what we currently generate on Earth. Another idea involves Hawking radiation. If we could find a way to control and capture the energy emitted by an evaporating black hole, it could provide an endless power source for civilizations advanced enough to use it. Could this be how super advanced alien civilizations power their technology? And if so, Could we one day learn to turn black holes into energy generators for humanity's future? Could a black hole change the speed of light? We assume the speed of light is a constant, but near a black hole, everything changes, including the way light behaves. Einstein's relativity tells us that light always moves at the same speed, but black holes bend space-time so much that light itself can become trapped. Some models suggest that near a black hole, light might not only slow down, it could actually stop entirely. But what happens inside a black hole? Could the fabric of space-time be so distorted that the speed of light varies, behaving differently, depending on where you measure it? If so, does this mean that the laws of physics aren't truly universal? And if we could manipulate the speed of light, could we one day alter reality itself? Could a black hole be used to create an artificial universe? If black holes naturally form new universes, could we intentionally create one? Some theoretical physicists propose that if we could generate a stable black hole and manipulate the quantum fluctuations inside it, we might be able to trigger the birth of a new spacetime bubble. This would essentially allow us to create an entire universe from scratch. But what would happen inside this artificial cosmos? Would it follow the same laws of physics as our own, or would it evolve into something completely unrecognizable? And if a civilization had already mastered this process, could we be living in a universe that was artificially created by someone else? Could a black hole ever become a star again? Stars collapse into black holes when they run out of fuel, but could the process ever be reversed? Could a black hole reignite and shine once more? Under normal physics, black holes don't produce light, but some theories suggest that under extreme conditions, a black hole could spit out the matter it once consumed, creating a high-energy, ultra-dense object that resembles a star. Some models even propose that if a black hole was bombarded with enough external energy, it might reach a point where it reverses its state, ejecting all its stored matter and transforming into something completely different. If this were possible, could it mean that black holes and stars are part of a never-ending cycle, one where black holes aren't the final stage, but just a transition to something new? Could a black hole create a false reality? Reality is defined by what we can observe. But what if black holes create an illusion, a space where what we think is real is actually distorted beyond recognition? Inside a black hole, space-time bends so severely that light paths are altered, time slows down, and the very structure of reality changes. Some scientists believe that if you could survive inside a black hole, your perception of reality might be completely different from what actually exists. Even more mind-blowing, what if what we call our universe is actually just a projection from a black hole's event horizon? Could everything we experience be the result of a simulation like reality caused by a black hole's gravitational effects? If so, then what happens if the black hole we're inside eventually evaporates? Does our universe simply disappear? Could black holes form inside a star? We know that black holes form after a star dies. But could a black hole form while the star is still alive? Some theories suggest that if a star's core collapses too quickly, a mini black hole could form inside it, before the outer layers explode in a supernova. If this happens, the star could continue burning for a while, feeding its inner black hole. But what happens next? Would the black hole eventually consume the star from the inside, causing it to disappear without a normal explosion? Could this explain why some stars suddenly vanish without a trace? If we find one of these parasitic black holes, it might change our entire understanding of stellar evolution. Could a black hole collapse the universe from within? The universe is expanding. But what if something inside it, like a growing supermassive black hole, could trigger its sudden collapse? Some theories propose that if a black hole reached a critical mass, it could cause a catastrophic chain reaction, distorting space-time so much that the universe would start collapsing in on itself. This idea, known as false vacuum decay, suggests that black holes could accidentally trigger the end of reality, turning the cosmos into an empty, lifeless void. Could a black hole somewhere in the universe already be growing beyond its limit? And if so, how would we even know before it's too late? Could we one day prevent a black hole from forming? Right now, we have no control over how black holes form, but could future civilizations develop the ability to stop a black hole from forming in the first place? If we could extract enough energy from a dying star before it collapses, we might be able to stabilize it, preventing a black hole from forming. Alternatively, some scientists propose that if we could manipulate quantum gravity, we might be able to control the collapse itself, perhaps even shaping the outcome to create something else entirely. If we could master this level of control, could we eventually engineer black holes to function exactly as we need them? And if so, Would we still fear them? Or would they become just another tool in our cosmic toolbox? Could a black hole store the history of the universe? We think of black holes as places where information is lost. But what if they're actually libraries of the cosmos, preserving a record of everything they consume? According to quantum mechanics, information can't be destroyed. This means that even though a black hole swallows matter, the information about what it swallowed might still exist, encoded in the event horizon or released through Hawking radiation. If this is true, then black holes could be time capsules, storing the history of long-lost stars, planets, and perhaps even ancient civilizations. Could we one day learn to decode black holes, unlocking secrets from the earliest days of the universe? And if so, could black holes be the ultimate archives of existence, waiting for someone advanced enough to read them? What lies beyond the final black hole? One day, billions of years from now, the last stars will burn out, the galaxies will fade, and all that will remain will be black holes. But even black holes aren't eternal. Through Hawking radiation, they slowly evaporate, releasing their energy back into the universe. So what happens when the very last black hole disappears? Some theories suggest that after the final black hole evaporates, the universe will be left as a cold, empty void. Others propose something more radical, that the disappearance of the last black hole could trigger a new beginning, releasing all the stored energy back into space, igniting a new Big Bang. If black holes are the engines of cosmic transformation, does that mean the universe never truly ends? Could we be living in a cycle where every universe eventually becomes nothing but black holes, only to have those black holes give birth to something new? And if that's the case, are we just one chapter in an endless story that has played out countless times before?